Welcome to cryptography session. Today I am going to explain symmetric encryption algorithms. There are two main types of ciphers are available. One is stream cipher and another one is block cipher. These stream cipher techniques were discussed in Unit-1, so which contains substitution, transposition, and steganography techniques. Substitution means replacement of one symbol by another symbol. Transposition means rearrangement of original message into some other format. So these are all stream cipher techniques. But if you take block cipher is treated for doing encryption or decryption in a collective way. That means we should take 64 bits of original message or a plain text as a block, or we can able to take 128 bits of plain text for doing encryption process. That is also called as block. And the same mode of operations, that means both substitution and transposition techniques are also used under block cipher, which means that block cipher implement few stream cipher techniques in it. So this is an overview idea of block cipher. Mostly all block cipher techniques supports fiestal cipher structure. So what is the meaning of fiestal cipher? So if you take encryption, we can able to implement encryption with several rounds. So minimum 10 rounds, 12 rounds or 16 rounds, we can able to do the same encryption mechanism. And for each round, we should use different subkeys for particular round. For example, I am using 10 rounds means 10 different subkeys should be generated from a given key. So this is the encryption process. Then if you want to do the decryption, that means the reverse of encryption, we use the same subkeys in reverse order. For example, in round 1, I am using K1 in encryption. In round 2, K2 subkey is used. In round 3, K3 subkey is used. In round 4, K4 subkey is used. Then I got a ciphertext. If you want to decryption, so this is round 1, round 2, round 3, round 4. In first round, the same key should be used for converting ciphertext to plain text. Then at round 2, K3 subkey should be used. At round 3, K2 subkey is used. At last round, we should use K1 key. Then we can able to find out the plain text. So if you do the same subkeys in reverse order, then that type of structure is called as fiestal cipher structure. So this K1, K2, K3 are subkeys. These are unique keys. So these keys will be generated from a common key K. So from this common key K, we can able to calculate 4 different subkeys. So the values of these 4 different subkeys are varied. But these 4 values will be retrieved from a common key K. So this is the fiestal structure notation. So this is an example of fiestal structure. And the second important concept for implementing block cipher technique is, if you want to do to design a block cipher, these 5 parameters that should be considered. One is the block size. Block size means the original text size. And then key size. What is the size of a key? How many number of rounds are used for doing encryption? The same number of rounds that should be used for decryption also. So for a particular algorithm, how many number of rounds are used? Then from the given key, in what way we can able to generate a subkey? So that generalized format is called a subkey generation algorithm. So which type of or which methodology of subkey generation is used for retrieving different subkeys for each round? And then the round function. So this round function contains both substitution and permutation techniques in it. So mostly all round function contains a stream cipher technique in it. So if you want to consider symmetric encryption algorithms, there are three different algorithms are available. One is simplified data encryption standard algorithm. Second one is data encryption standard algorithm. And the third one is advanced encryption standard algorithm. So these three algorithms are available under a symmetric encryption model. These three algorithm design contains these five features in it. Only difference is the size of block, size of key, number of rounds, and the round function operations are different in each algorithm. But these three algorithms contain these five common features in it, and in which simple DES and DES follows Fiestal cipher structure. But AES does not follow Fiestal cipher structure format. Let us discuss each algorithm later. So the first algorithm is a data encryption standard. So it is the most widely used block cipher encryption algorithm, which was derived at the year 1977. Another name for data encryption standard is data encryption algorithm, which contains block size as 64-bit and key size is 56-bit key. So this is the main important thing. So the block size of DES algorithm is 64-bit. The key size of DES algorithm is 56-bit key. And it is purely based upon Fiestal cipher structure concept. So this is the five major features: block size, key size, number of rounds, subkey generation, and round function. Block size of plain text is 64-bit. Key size is 56-bit key. Number of rounds are 16 rounds. There are different subkey generation algorithms are available, and four basic operations are performed under round function, which are all namely expansion, XOR operation, substitution, and permutation. Another name for transposition is permutation. So in the forthcoming videos, we only say the permutation instead of transposition. You should aware of the term. So this is an overview idea of data encryption and decryption. So encryption left side part, right side part is decryption. If I want to do DES encryption, plaintext size is 64-bit. The same ciphertext bit is also available. The size of ciphertext is also 64-bit, but the key is used with 56-bit key. If you do the reverse process, it is a decryption process. Decryption is done for a ciphertext and we can able to retrieve the plaintext with the same set of key. So this is an overview of DES encryption decryption. So this is the generalized model. So the left part is plaintext, the right part is key. So plaintext size is 64-bit. Then step 1 is we should do initial permutation. Permutation means the rearrangement of these 64 bits in some other way. So this is the first step. And second step totally 16 rounds are used. And each round, each subkeys are used. Totally 16 subkeys should be generated for 16 rounds. Then after the 16th round, we should do a 32-bit swap. After that, the fourth step is inverse initial permutation. Then only we can able to get a ciphertext value. So this is the 4-step process. First step, initial permutation. Second step, round function operation. Third step, 32-bit swap. And the fourth step is inverse initial permutation. So, okay, are you clear about it? So this is the plain text side. Then if you take key side, if the key is given a 64-bit key, for each round only we should use 56-bit key. So in a diagram, in a previous diagram, we are aware that only 56-bit key is used for encryption purpose. But if the key is given with 64-bit key, then you should use permuted choice 1 for reducing the 64-bit key into 56-bit key. Then for each round, we should generate different subkeys. So here K1, K2 are called subkeys. For each round, different subkeys should be generated. How can it be generated? Means we should perform a left circular shift. For each round, from the given set of 56-bit key, we should use left circular shift. Then the values will be deferred at each round. So totally for 16 rounds, 16 left circular shift will be done at the key side. Then in the round function, the key should be used as 48-bit. So we should reduce the 56-bit key into 48-bit with the help of permuted choice 2. So this is the third operation which is done at subkey side. So at plain text side, 4 operations are done. At key side, initial 64-bit key is reduced to 56-bit key with the help of permuted choice 1. And for subkey generation, we should use left circular shift, but the bit is 56. If you want to implement each round function, 56 instead of 56-bit, we should use 48-bit subkey. So we should use permuted choice 2. So this is an overview of DES encryption. Thank you.